Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. This is Engineer Finally, and I am the instructor for this course of high-rise building. And due to the busy schedule, I am recording this demo session for you to clear the doubts of many students. That will be what will be included in this course. So we will have regular classes and sessions from coming Monday, it is 10th of January 2022. Let me go through this training course quickly and show you a brief introduction what we'll be doing in this course. This course has been divided into 10 sessions that is already shared with you guys, and it may be we will end up in session 12 sessions and 14 sessions depending upon our speed. So in the first session we will have a general discussion of design practice, that what is the design practice in Pakistan and all around the world. And then we'll go through the types of the building system, types of frame system, and then introduction to the building code, that is ACI 318, and then BBC 97 building code of Pakistan. In the definition of the types of the building system, that we have the different types of the frame system. We have mainly 4 types of the frame system, that is wall bearing system, building frame system, and then moment resisting frame system, and then a dual system. So we will discuss this in detail, what are these systems and how these systems resist the earthquake loads and gravity loads, and how the codes have been defined these frame system, and what is the response modification factors for different type of system, and what does it mean if we have R value 5, and what does it mean if we have R value 8.5. So we will discuss this in detail, and then we will go to the types of the slab system. In this training session, we will be having, we will design beam slab system, in which we will have slab, beam, and then the load will transfer into the columns. And then we'll briefly define what is slab system, what is flat slab system, flat plate system, and what is joist system, two-way joist system, one-way joist system. We will discuss this in our first session, right? And then we will go through the different type of the codes, ACI 31814. We will go through its chapters, what are included in this code, and we will designing our frames, slabs, columns, and then retaining walls and shear walls. We will designing these in ACI 31814, and we will defining our minimum loads that will be applied on our structure. We will be using ASC 710, and then for earthquake definition and all the drift calculation and torsion irregularities, and we will using UBC 97. So we will go through all of these codes briefly in our first session. In our second session, we will be introducing what is ETABS and SAFE. Many of you are familiar what are these, but we will briefly discuss what are different tools and how we use these tools in ETABS and SAFE. Then we will go towards the modeling of the proposed building in ETABS using architectural drawings, and then we will have a discussion on the engineers-architect interaction, right? In the modeling of the proposed building, we will model our structure using 3 methods, right? I will show you the 2 methods, but we will be designing our structure with one method properly. The 3 methods are that the first method is you directly import your architectural grids, your architectural columns, beam, slab into the ETABS, and you start working on that. Let me show you that how you import. For example, I have prepared this. This is the DXF file of AutoCAD. How you prepare this DXF file to import ETABS, I will show this in detail. So the architectural grid has been imported into ETABS directly. Now you can draw your columns, beam, and slab using these grid lines. If you have very irregular grids, you cannot identify on which grid intersection of the grids I have to draw my columns and beams. So you can directly import your columns, and then you can draw your beams, slabs, and shear walls, all of these. Let me show you how. I have prepared the DXF file for the columns from architectural drawings. You have to import architecture plan. This is column DXF. So these are the column architecture columns I have imported in ETABS. Now you can draw your columns on these architecture columns. On the right side, you can see the column has been modeled in ETAB using these joints. Now you can draw your beams. So all of these will be discussed in detail how you do that. The second method is use the grid lines in ETABS if you do not want to import your architectural grids and architectural columns. You have to, when you open this new model window will be open, and then you have to define number of the grids and number of the stories, the height of the story, all of these, and you have to click on the grid only and click on OK. So the grids will appear, and now you can modify your grids, the size of the grid, and then the spacing between the grid lines and its orientation, its origin. You can edit from this ETAB model. Now you can draw your beams on your ETAB grids and your columns, right? So this is the second method in which you use the ETAB grid lines. Now the third method is to use the quick template that is already built in the ETAB. That is, if you are designing two-way slab, waffle slab, flare slab, you click on the template and you define all of the required information, beams, columns, slabs, and then you define the number of stories, and then you click on OK. Then directly the model will appear and will be model in your ETAB. So here you can see there are three methods in which you can model your structure using architectural drawings. That is, directly import grid lines or columns using quick templates and the grid lines. We will discuss this in detail in our session 2. In session 3, we will continue our modeling, and then we will start defining of material properties, section properties of beams, columns, walls, slabs, according to ACI 31814, right? We will be defining how you define FC prime concrete, how you define concrete if you are using 450, for example, 4.5 KSI FC prime. So there's not included in this already built-in properties, that is 300, 400, and 500. You do not have 4.5 KSI. So how you define it, how you calculate modulus of elasticity for that. So we will discuss this in detail. How you define steel properties if you are using grade 60, 70, 80, and 75 grade steel, how you define the properties for that. We will be discussing this in detail. And then we will go towards the definition of the frame section for the beams and columns, and then walls and slab. We will be starting from the minimum requirement of the code, that what code says that what should be the minimum depth of the beam, what will be the size of the column, and what will be the thickness of the slabs and walls and the ramps if you are using in your structure. So we will be defining it according to the ACI 31814 using its different tables that is given in its chapters. And then we quickly go through what is included in this new property of the frame structure. That is, you can see the different templates. What is section designer and how you utilize the section designer, what is its uses, where you can use section designer. And then we will define the property modifier, that is the stiffness modifiers, how we use stiffness modifiers for beams, columns, and if what will happen if you do not use property modifier, stiffness modifier in our structure. We will define this in detail. What are the value for stiffness modifiers according to ACI 31814? We will be using that. We will be not doing any detailed manual calculations for the design of the frames systems, for example, for the beam columns, but we will manually check one of the column and beam. We will manually check according to the ACI, what are the minimum reinforcement in column, what is the minimum reinforcement in beam, what is the minimum reinforcement in slab and retaining wall and shear walls. We will be checking it manually, but we are not doing a detailed manual calculation. but we will checking it for a beam or a column, or we will checking it manually for the requirement of the ACI code 31814, right? So we will discuss this in detail, how you define frame properties, beams and columns, and then we will go towards the definition of the slabs, that how you define the slab, what does it mean if you use shell thin, shell thick, what are membrane and layer. We will discuss this in detail, and then we will select what are the type, drop, stiff, rip. We will discuss these, what are these and where you use it, right? And then we will go towards the definition of the shear walls and retaining walls if you have any basements in it, right? So same is for the slab, shell thin and shell thick, right? So we will discuss this in detail, and how we will come up with the economical section to select the that will resist your loads, and as well as it will be economical for the client. If you are using, for example, if the required minimum depth is 12 inches and if you're using 30 inches, so it will resist your load, but it will be uneconomical structure that will not will be accepted by the client. So we will selecting economical structures according to the code, right? So this will be the session 3, and then we will go towards the session 4, in which we will assign the section to the structural members using different methods. There are different methods where you can assign structural section to the structural members. The one is that you select all of the elements that you want to assign a specific section, and then you assign that section to it. And there are other methods, 1 and 2 other methods. We will discuss this in the our proper classes, right? And then we will go towards the definition of the load patterns. That is what will be the load patterns for our structure, super dead load, how we define the earthquake loading, right? And what will be the load combination. If you are using UBC 97, you will define that load combination as per UBC 97. If you are using Indian code, you can define that. If you are using Euro code, you will define load combination according to that. And what will be the load cases, and what is the concept of the mass source, and how you set that mass source in ETABS, that the software properly design your structure, right? So let me show you quickly that in load pattern, when you define, for example, if you're defining earthquake, you will select the seismic, and then you will select that code, which code you are defining your earthquake. So you're using UBC 97, you will add, you will modify, and here you will add some of the important information for the earthquake. What is the zone of the structure you are designing, that is you select for the zone, what is the soil type, and what will be the direction of the earthquake, what does it mean for CT, what is CT, what will be the response modification factor R 8.5. But what will happen if you insert 8.5 or insert 5 or 6.5? So how the software designing it, if the R value is increasing, decreasing, the structure of the economical, uneconomical, what is the importance factor? We will discuss this in detail. What will happen if the R value is greater or smaller, the structure will be economical or uneconomical, the structure will be safe or unsafe. We will discuss this in detail, right? So this is we will define the load patterns for our structure, that is earthquake. And then we will go towards the load combination, where we will define our load combination for the specific code which we are using, and then the scale factor. What is scale factor? We will discuss this in our proper classes. You can also add default structure in which you have code selected for the design of the frame structures, right? Then you will go towards the definition of the load cases. What are the load cases, and how if there any requirement to modify these load cases, we will discuss this in detail. And then you will go towards the mass source. What is the mass source, and how you define a mass source according to your code, and how the structure and how the ETABS applying the base shear on the structure, that will depend upon your definition of the mass source, right? So we will discuss this in detail, how you define mass source, what what forces will be, what loads will be included in this mass source, and how the code define that mass source, right? So this will be the end of the session 4, that we will define all of these, and then we will come towards the session 5, assigning of the loads to structural members as per UBC 97, right? So we will be using a C710 for the assigning of the loads. But when you see the ACI 31814, or when you go through the UBC 97, it will always mention a C710 for go to this code for the minimum load requirement. So we will assign different type of the loads. We will assign area loads on the shell elements on the slab, and then we will partition loads we will apply on the beam. If we have any partition wall resting on the slab that is not coming on the load is not coming on the beam, what we will do, we will assign different type of the loads on this slab to incorporate the load of that partition wall. So we will discuss this in detail, and we will apply that load on the slab or the beam. We will discuss during this session. The next will be selection of the desired code. Where will you select the desired code for the design of your structure? Will be designed, for example, let me show you for example, if you are designing concrete frame, so you will go to preferences, and from here you can design select your desired code, UBC 97, Indian code, Chinese code, whatever you are designing your structure to that, you will select desired code from that list, right? And then we will have analysis and then discussion of the result, and we will done our analysis, and then we will have discussion on different type of the results, how you show your deformed shapes, what will be the stresses in the slabs, columns, beams, and what will be the bending moments, especially in the beams and columns. We will be showing different different options that are available in ETABS. So we'll be discussing all of these results in these sessions. For example, I have run this. This is already run model. Let me show it undeformed shape. For example, if you want to see the deformed shape due to a load combination of the dead, we apply that. It will show you the deformed shape of that structure according to that load case. Right? You can show the start animation, and for example, if you want to see the bending moments in the beam, software will show you the bending moments in your beams, right? In your columns, in your shear walls, in your slabs also. This is the bending moments in your beam, and that was the M33, right? You can also see the stresses in your slab if you are doing it. For example, someone is doing this research or want to see the stresses in the slabs. You can see it from the shell force / stresses. It's a heavy structure, it's taking time. So this is, you can see different type of stresses in your slab using these commands that is from the display, and force stress diagram and shear stresses pairs. And for example, if you are interested in the base reactions, you can display it by going to the display, forces / stress diagram, support springs. It will appear, and it will asking you whether you want to plot an area or a table. I want to show a table in FZ. So it's showing you for the case of the dead, it's showing the reaction. These are the reaction that we'll be using in the designing of the foundation, right? So all of these will be discussed in detail. So that will be the end of the session 5. In session 6, we will be checking the drift, and then we will be touching irregularity in a proposed building as per UBC 97. If there is any drift, what will happen if there is any drift? that is greater than the limited value of the code, and how you find the solution for this drift, what will happen, and what is torsion irregularity as per the UBC 97, what are its limits, and what will happen if it's beyond the limit of the code. So what will we do? So I have prepared the 2 Excel sheets for these checks. For example, this is a drift calculations, in which, for example, if you have time period greater than 0.7 second, so drift limitation is 2%. So how we use this Excel sheet using the data from the ETAB, you insert these data, what is delta S and what is delta M as per the UBC 97, and what are the drift percentages. If the drift percentages is greater than 2%, what we will do? If it is less than 2, that is we are fine. So we'll be discussing this in detail, and then we will have the torsion and duty check Excel sheet. I have prepared this. You will insert the values from the ETAB, and this Excel sheet will show you your structure is irregular at this story or this story, and what will you do if you have irregular structure. So we will be discussing and designing it in detail in our sessions, right? What is the amplification factor and what will eccentricity, new accidental eccentricity according to UBC 97. All of these are we will be doing as per the code UBC 97. So we will be having a drift check and the torsion irregularity. So in these sessions, we will learn how to check the drift and then check the irregularity in the building. If you have no issue in drift and torsion irregularity, that is fine. So if you have irregularity and drift issue, so what is the solution? We will talk about the solutions of these 2 problems, right? So that will be the end of the session 6. And then we will go towards the session 7, that is the designing of the beam, columns, ramps, and slab. So this is already this is the building that I already designed. We have designed it in the previous training session. So I will show you what are these values that are showing on a display. That is concrete frame design, display information that is showing. Now you are seeing the longitudinal reinforcement in the beams and columns. That what does it mean? 0.83. What is 0.2? What is 0.4? What is in the column reinforcement? What is 5.78? If I right click on that, a window will appear. What are these options? We will discuss in detail. For example, if I click on the summary, a report will generate. It will show you different information of the column that is being designed according to ACI 31814. What are these values and how the ETABS calculated it, we will discuss in detail. If you want to check the beam column joint, you can check it from here. If you want to check the capacities of columns and beams, you can check it from here, drop down list. If you want to check all the failures that has happened in your structure, you can check from this. We will discuss all of these in detail in our sessions, right? So in concrete frame, what are these different options? What does it mean by view, revise preferences, overrides? What is overrides, and how you define your stories to be designed? For example, this is the chain design section, and this is, for example, select the design combination. If you are doing it for only gravity loads, you will select different load combinations. If you are not incorporating some of the combination, you can delete or insert that combination from the design of your frame, right? So this will be the design of the beams and columns. Let me show you in plain. That I have changed the load combination, that's why it's not showing any reinforcement now. So you have to run it again. So in this session, we will be designing beams, columns, slab, and ramps, and we will be calculating its reinforcement according to ACI 31814. What is the minimum reinforcement in beam, and then we will check it manually, and then we will compare it with the ETAB. What is the minimum reinforcement in the column? We will calculate it manually, and then we will check the results of the ETAB. Similar for the ramps, slabs, and the walls. In session 8, we will be designing shear walls, lift walls, and retaining walls if you any basement. In this session, we will be designing a shear wall in our ETAB, and we will be discussing what is pier, what is spandrel, how you define it. For example, this is the shear wall design menu, in which you can see similar definitions of the revised preferences, in which will you select the design code, and then all of these properties. So we will be discussing it in detail, how you design our shear wall, retaining wall, and lift walls, right? What will be the load combination for these, and how you use section designer for designing of the retaining wall, shear wall, and lift wall. We'll be discussing it again. We have different options. We have three types of the methods for designing and shear walls and lift walls. That is the simplified CNT compression and tension design, uniform reinforcement, and general reinforcement. Normally in design practice, uniform reinforcement is used, right? So we'll be discussing these in detail. And then we will come towards our session 9. That is the most important, that is the modeling and design of the raft. And we will be focusing on the punching check, punching shear check, integral beam design, and safe, right? We will, this is a model I have already designed it. It's showing the punching shear check in raft for the column. That is, its value is 0.54. What will happen if its value is greater than 1, and how you decrease its value from 1, what is the acceptable criteria for the punching shear. We will discuss in detail, right? How you design integral beam in raft using safe. We will be discussing that in our sessions, right? And how you design raft in different layers. I think you have seen in raft there are different layers given, layer 1, 2, 3, 4, and how the engineers design these different layers. We will be designing different layers, 2 layers, 3 layers, 4 layers, depending upon the demand and number of the stories in this ETAB safe model, using ETAB data in ETAB results, right? Let me show you our one of the project we have done. That this is a raft, 36-inch raft, and we have columns, retaining wall. So we have given 3 layers. That is, 1 layer is continuous, and then other layer, and then the second layer, and third layer, right? And the left side we have only 2 layers. So how you decide number of the layers? What will be the length of the layers? For example, this length of the layer is 15, and this is 13. So how you decide the length of the layer and number of the layers? We will be discussing it in detail using safe software, right? So in this session, we will be only focusing on the design of the raft, using for mainly focusing on the punching shear check in design of the integral beam, and then design raft reinforcement in different layers, layer 1, 2, 3, 4, depending upon the demand. In the last session, we will be checking serviceability checks for the and detailing of the slab, column, beams, and structural walls in raft. Serviceability check means the deflections of the structural members. The serviceability check is mainly done to check whether the non-structural elements like windows and partition wall will be cracked or not due to the deflection of the structural members. We will be checking according to the ACI 318. And then we will be doing a detailing of the slab, column, and beams. Like, for example, this is our detailing of the raft of one of our practical project that was 9-story, I guess. It was in its construction is in Gulbahar, right? So we will be doing the detailing of our proposed building using AutoCAD. So how you model, how you detail that, right? So we will be detailing our raft, beams, columns, and we'll show different. We will show the reinforcement of these structural members using AutoCAD, right? So this was the whole summary of the training course. I hope you are many of students have doubts in their mind whether to take this course or not. If you have any doubts, still in your mind, you can ask me questions in WhatsApp, or you can email, or you can personally text me on WhatsApp, and I will answer you and I will clear your doubts. The last thing I have forgot to mention that we will be doing response spectrum analysis in this training course, right? There are different limitations of response spectrum analysis, that you will not use response spectrum analysis on every building. So we will be discussing in this how you analyze a structure using response spectrum analysis, and when to use response spectrum analysis and when to not. We will be discussing that in detail, right? So we will doing a linear elastic design of a structure, and we will doing response spectrum analysis of the proposed building, right? So if you have any questions still in your mind about this course, you can ask me, or you can ask Muhammad Irshad, Engineer Muhammad Irshad. You can ask in WhatsApp group, or you can text me personally to clear your doubts, right? Thank you very much.